Good morning, good afternoon, good evening guys, gals and gentlebuds, and welcome back to the shed. Back in the shed. Little job today. A couple of videos ago I showed you how I made some polyurethane bushes for the rear suspension. Well, now I need to make some bump stops. That's what was on it on one side, the other side was completely missing. The original would have been about that tall, but because it's got lowered suspension it's been cut off. It's still a bit tall. I don't really want to run without them, because if they aren't there, the axle can hit the chassis solidly and that wouldn't be very good. So I want to make some polyurethane bump stops. So I'll reposition the camera and I'll show you what we're at. Right, so I've got my scales, I've got my mixing pot, I've got a better mixing stick this time. I've got my polyurethane mix, should be enough to do these two. Now I've gone through a bit of a process with this. So this was the first mould that I designed for it. It's a simple dome and this plate, which is an aluminium plate, 50mm diameter, 3 small holes drilled in to give the PU a chance to run through and bond, and a bolt tapped through the centre of it so that it's got the stud to fasten it to the axle. So that would sit in there, fill up with polyurethane, that would sit in there, polyurethane comes through the holes, runs around the bolt head, makes a good bond. Nice stuff. Except I didn't make these walls tall enough, and I made a mistake in the bushes design, in that, not so much in the design but in the operation. I didn't use a release agent. I actually did on the last 2 out of 8. I realised at number 7 that I hadn't put any release agent on the moulds, which is why they were so difficult to get the bushes out of the moulds. So I used a bit of wax, rubbed that around the inside of the moulds, and lo and behold the last 2 came out a lot easier. Now, talking to a good friend of mine yesterday who is a pattern maker, mould maker, he's been in that business since he was 16 and he's roughly the same age as me, so I think he knows what he's talking about. And he said this: you need to use a release agent. If you're doing GRP or carbon fibre mouldings, you use a release agent. Exactly the same in this process. It just stops the polyurethane getting a bond to the mould. So I'm going to wipe the inside of the mould. Now you're probably wondering why I cut a quarter out of that. I will explain in a moment. But another point he suggested was to put a hole in the bottom of the mould there. Plug it. He suggested using plasticine, but I haven't got any plasticine. So what I've done is I've tapped it to M6 and I've cut an M6 bolt down, and that just screws in there. It doesn't quite come flush, but that's not a problem. I'll fill that with wax when I wax the inside of the mould. But the point is, when it's dried, when it's cured and you want to take it out of the mould, the release agent will help, but the second thing that you're fighting is vacuum. The part in there will create a vacuum when you try to pull it out. You're pulling against suction. So by doing that, you can then put an airline blowgun onto there and pop it out. So that's what I'm going to try. Now, because it only took a couple of hours to print the mould, I've done 2, because I need to do 2 bump stops so I can do them both at the same time, rather than doing one, leaving it 12 hours, taking it out, doing the second, leaving it 12 hours. So I'm going to do the 2 in one go. They're both the same. You'll notice another difference in the moulds. this one's got an indent in the bottom simply to clear the bolt head, so once it's poured it will sit on a flat surface and not wobble about. Nothing more complicated than that. The reason I cut a quarter out of that is to show you the development of it, and I'll come to that later. A little bit later in this video I'll show you the design development in a 3D CAD design program, and how I came about it and how I designed it, and then a little bit on the printer and how it was printed. Right, let's get to it. Now obviously these have got quite a much bigger volume than the bush moulds, so I'm going to need to mix a bit more up, but the first thing is to rub that wax all around the inside of the mould. This is where the fact that the printer prints in layers, so you get very fine steps up the side of the mould. It actually helps with the wax because it forms almost like a file surface, if you like, so it will rub off the end of the wax, but it also means that the wax smooths out those ridges, thereby again reducing the chance of the PU sticking in the mould. The reason I've done a bigger lip on this one, so that sits deeper in it, is because I want the polyurethane to come through those holes. So when I pour it in there, I want to come up just above that step, so when that goes in, the polyurethane will ooze through those holes. But in the original design, where it was a very shallow step, just deep enough for, well, it wasn't even the depth of the thickness of that material, thickness of that plate. So if I put too much in the mould, it would have oozed out, run down the outsides and made a right mess and made it even harder to get it out of the mould. So that's why I've got a deeper lip on that one. Yeah, I must thank Rob for the advice on doing this. It's gratefully appreciated. Every day's a school day, and we're never too old to learn. Rob did say you could use furniture polish. Silicone furniture polish is brilliant because the polyurethane won't stick to the silicone. That will come off very easily, and that's nicely coated. I'll do the other one, and then we'll get mixing it and pour it down and see how we go. Right, that's my two moulds waxed. The bolts are in the bottom, so I'll pop them there. I've got my two base plates, so they just form that plate and stud, so that will go through the bracket on the axle and have a nut on. Right, so as before, zero the scales. I think I'm going to go with 40 grams between the two, so 20 grams of each. Okay, 21 grams, was close. There we go, 42 grams. That may be enough for one. We shall see. So that needs a good mix up, as before. That'll be a few minutes of stirring, and then we pour it into a mould and see what we've got. One thing I am going to do is sit the moulds on a sacrificial piece of plywood, so that if it does run over the mould, or if I spill it, it ain't going to make a mess of the bench. There we go. I want that to come just over the lip, or just up to the lip, because obviously the volume of the bolt head in there is going to bring it up bring the level up slightly, and just shuffle that around a bit to make sure the PU gets under the bolt head. That's looking pretty good. Just see it through the holes, maybe just a tad more then. Just because I actually want it to come through those holes, if it will, to get a good key. Yeah, that's better, because I can cut those bips off after once it's cured. Right, well, that was actually just about the right volume for one, so I'll do another one. Right, pour that one into there. I think that should do us. It's probably a good idea to wear some gloves when you're doing this, because it's quite sticky on your hands. I may have put a little bit more in that one. Because there's quite a bit oozing through, but that's fine, because as I say, once it's cured I can cut that excess off. It's more important that the polyurethane gets a good grip on that metal, because I don't want it coming off. So yeah, that's it. I'll leave those overnight. I'll have a look at them in the morning and see if we can pop them out. Let's go to the PC and I'll show you what I did. Right, so here we are in my study, computer room, hidey hole, cupboard, call it whatever you like. So the reason I cut that piece out of the original mould was just to explain the way I did it is to imagine a slice through half of the width of the mould, because I designed it around a central axis. So I just designed one half of it and then did a rotation around that axis. So that shape is the basic shape that I drew and then rotated around the central axis. I'll show you what I mean. Right, so the program I use is FreeCAD. Just takes a moment to boot up. And we do create new. Select part design from that drop down menu. Then create a create an object, create a sketch, and I want to do it around a vertical plane, so it's either the XZ or the YZ plane. We'll go with the XZ, doesn't matter which really. So that line, that green line there, is the vertical centre line of that mould. So that green line there is that line there. If that makes any sense. If it doesn't yet, it should do hopefully soon. Right, so I need to do a basic shape. So when you're doing this, you see we get a vertical red line there. That means that line is vertical. If I go off vertical, you see it disappears. And likewise When I'm doing that way, it goes horizontal, shows me horizontal bar to show me horizontal. If I go off horizontal, it disappears. That's my basic shape for this one. And then if I do a radius with centre and end points, and you'll see that line is shortened down to accommodate because that's where I started. So now we need to dimension some of these bits. The overall diameter of the finished job is 50mm, so that radius wants to be 25. Constraint radius 25. We only need 1.5mm there, so that line needs to be 1.5. I think I did 1.5 mil. Just move that so that it's more visible. So you can either click on the line or you can click the end points of the line to dimension it. And if you've done more than one, it tells you off. That one can be 1.5. And that one can be, I think I did that at 1.5. Because it doesn't need to be very thick, there's no real pressure on it. When you've got all of these dimensions are called constraints, so you're constraining the dimensions of each individual segment of the model. I put that there, we can see it a bit better. So if I do that, you know, if that's 25, that plus 1.5 plus 1.5, so 25 plus 3 is 28, so that should be 28, and that has automatically made, move that down, that has automatically made this one the right length because we've constrained everything. So we say close that, and now over here on the left hand side in the menus we go to revolution, and as if by magic, there it is. Right, so that's that one. So we say OK to that, and now we would save that, and then we can export it as an STL file, which we then run through a slicer. I'll come to that in a moment too. So let's save as, make a new folder, call it Naughty Bump Stop, and we'll just call that Bump Stop, and that saves the design in FreeCAD's own format. Now, we need to export that as an STL file so that the slicer program can read it and understand it. And what the slicer does is literally slice the model in a vertical step form. slices it to whatever thickness you've determined your print layer to be. I use 0.2 of a millimetre in this case, so it slices it into 0.2 of a millimetre thick layers, and it works out what's called G code, geometric code, which the 3D printer can understand. It's the basic instructions that tell the 3D printer where to move the nozzle to and how much to extrude of the melted material. So if we select the body, and that's now gone green, come down here to export, and it's now changed it to bump stop dash body STL. Save. So we launch the slicing program. Quiditech is the maker of the printer that I'm using. It's a Quiditech X Plus. I'll download the latest version next time I use it. So this is the slicing program. The basic slicing program is called Cura. This is Quiditech's own version of Cura. They put their own front end on it, if you like, but it works very well. So if we go to multi bump stop body, and there it is. Now we can roll around that in 3 dimensions and view it and look at it, and when we're happy for what it is, this is the basic print area, the bed of the printer. So then we check that our settings are what we want. Layer height 0.2, extruder is a 0.4mm extruder, layer height, infill density. Infill, it doesn't print it as a solid block because that would take far too much. But if you can see that, you see the actual inside is hollow and it's made up of lines of material. It prints a 3-dimensional pattern to give support to the walls, but it saves on material and saves printing time. If that was printing with a 100% infill, so it was printing as a complete solid block of plastic, that would probably take about 14 to 16 hours. As it is with, we don't need a 20% infill because it's not a structural part. 10% infill will be fine. So we're happy with all the settings. We do slice, that gives me the basic print parameters. I'm happy with all of that. We tell it to slice, the computer's working out, and that will take 1 hour 55 minutes to print, and will take 20 grams of PLA filament, which will be 6.76 meters of filament. So that's that. So now I would save that to disk, save it to an external memory card, plug that into the printer, and the printer will do its job. Right, we've fast forwarded about 15 hours since I poured these. Let's see how they come out of the mould. I was going to pop them out with an airline. I've got a compressor here, but for the life of me I cannot find my blowgun. So we're going to have to see if they'll come out manually. Oh, that feels good. Oh, look at that. That looks pretty damn perfect to me. Let's see if the other one will come out. Take that bolt out the bottom to allow it to breathe. Doesn't matter if I damage these moulds because I only need to make these 2. Oh yeah, perfect. Just tidy them up a bit, trim off the excess and those bips, and they're good to go. Fantastic. Well, happy with that. I hope you found this interesting. Thank you for watching, and I'll see you in the next video.